a simple project here to compare the results of object-based and pixel-based in mapping high-resolution image array, specifically in Kampala. Yeah, so I'll have a background, objectives, the methodology, the results, conclusion, and then who are some of the people who can benefit from this research. So, okay. So, of course, from a planning perspective, when you are doing planning, you need to know information about the cover of a particular area. And then I'm very well sure, and we also know, that when they are planning, planners will always want to deal with land cover, and more so in developing cities. Yeah. So, but then the advantage we have is that in this generation, high-resolution imagery is not a problem. Actually, you can even get, up to 50 centimeters of any place you want at any time. So that's the advantage we have. So for my study, I wanted to compare two image classification approaches, pixel-based and then object-based classification, and then to see which one is the best in terms of what? Of classification, but specifically on high-resolution what? Imagery. Because high-resolution imagery is different from what? From coarse or medium. So to give just a simple background, for the pixel-based, if you have an image, it's divided in 2 pixels. If it lands at 8, it's 30 by 30. So if you use a pixel-based approach, each pixel will be classified into a given class, depending on the classification scheme you are using. So for the object-based approach, it's different. You first segment your image into objects. And then after, you train a classifier to classify those segments into objects. And then from that background, you'll have an image classified into what? Objects. So, yeah, the main objective to compare OBIA and then pixel-based. So first, we had to classify high-resolution imagery using OBIA and then pixel-based what? Methods. And then after, we do accuracy assessment, and then you evaluate, you compare the results from the 2 classifications. So this is a simple methodology. I used playtest imagery. Of course, you pre-process it, and then select a study area. After that, you select training samples for the OBIA side, and then training samples for the pixel side. And then at the same time, you also select the testing samples before you jump into the training. So after you segment your image, and then after segmenting it, I use the support vector machine to do the classification. And then this side of the pixel-based, I used a maximum likelihood classifier to do the classification. And then after, I assessed the accuracy, and then I compared what? Results. So since Kampala is very big, I chose a study area, that area in red. And you know, high-resolution imagery is very big in size. So I was using a resolution of 50 centimeters. So for such an area, it's already big in what? In size. So I just chose to subset my study area. Yeah, so this is my study area. As you can see, we have a number of what? Features. We have the roads, the trees, and the lawn, and then we have a number of features, you know? So for my study, I considered only what? 4 classes: the trees, the lawn, the buildings, the bare ground, and then the roads. So these are the results for pixel-based what? Maximum likelihood classification. So, okay, this projector is not nice. But the challenge with pixel-based methods is that the algorithm will create a classification based on pixels. And then from small remote sensing, we know that the roads, the buildings, and the bare ground are related in terms of what? Reflectance. So you will always have problems of misclassification of those what? 3 classes. And actually, since you're having high resolution imagery, you'll always have like crystal-like structures in your what? In your classification, as you see here. So that is the results from what? From the pixel-based classification. And then, so that is the OBIA. For the OBIA, for it looks at what? Objects. When you segment your objects, whether you've segmented them poorly or correctly, the classification will deal with those segmented what? Objects, not the what? The pixels. And then actually, I was impressed with this because, first of all, as you see the one in red, they are the buildings. You can differentiate buildings from the roads, and then from the what? From the bare ground. Of course, it also has some misclassification, but not to that extent of the what? Of the maximum likelihood. Yeah. So if I can take you through, small, you see this image? Just look at the buildings. They are distributed, but they are regularly shaped. And then look at the pixel-based. Are you seeing how the building class is confused with the bare ground? And then when you look at OBIA, wow, you can't just imagine. The buildings are already classified in their what? In their class, yeah. So, further, in summary, of course, OBIA performed better than what? Than maximum likelihood, with an accuracy of 87.5, and then pixel-based had an accuracy of 85.2. And then, of course, OBIA achieved better separation of what? The 3 classes, the roads, the buildings, and the what? And the bare ground. But then, have it in mind that this is high-resolution what? Imagery. So if you are dealing with Sentinel-2, Landsat 8, or MODIS, I don't know what it will give you. Yeah. So, in conclusion, OBIA, for my study, I can conclude that OBIA performed better than pixel-based maximum what? Classification. And then, of course, I would encourage more researchers to dive into OBIA and its application for urban what? For urban mapping. Yeah. Who can benefit from this research? Of course, a number of people, KCCA, NEMA, and any other researchers in the world. Thank you.
Okay. Yeah, thank you very much, Jesse, again, for really giving an insight on how we can process our satellite imagery. So I'll take this opportunity to invite 1 or 2 questions to Jesse, and thank you very much for keeping time, Jesse.
Thank you.
So online, okay, someone is saying that isn't it, don't use the name, is it obvious that OBIA would yield better results?
Well, it's not obvious. That's why I've told you, you just have to have it in mind. If you have worked with Sentinel-2 or Landsat 8, then you know that, okay, I've worked on both cases. I've worked with Sentinel-2, and then how I reached on this, I had a small assignment where we were classifying high-resolution imagery. And then we used pixel-based, but then I was not satisfied. But it's not obvious.
Okay, any other? Yeah, maybe you hinted a bit about it, because I was going to ask that, what about when you have lower resolution satellite imagery? How do these perform? But you said maybe someone should investigate that.
Okay, well, but then, of course, let us consider a simple case of Landsat 8, 30-meter resolution. So, if you want to differentiate between roads and buildings at that resolution, still using OBIA, I will laugh at you. Because already the spatial resolution is, but you can do that. But again, at that resolution, I would take the maximum likelihood.
Okay. Do you think these 2 methods will perform differently depending on the predominant land cover or land use? An example, urban area and rural area. I see yours is an urban area here. Do you think it would the comparison would have been different if you were in a rural area?
Well, I think it will not be different because when you go into the rural area, you will concentrate on the classes in the what? In the rural area. Why I concentrated on the urban is because always we need, for planning, we always need information about the what? The urban. And I just want to demonstrate that if you have such a task, you just need to dive into Obia and then leave the maximum likelihood that side.
Okay, thank you very much, Jesse.